Welcome to this predicted paper from onmaths that is based on the advanced information given to us by the exam boards. Please use this paper in addition to your other revision. You can complete a unique version of this paper by going to our onmaths site. Onmaths is full of free content to help you prepare for your exams, such as topic-based papers, demon questions and mini mocks. If you like what we do, please consider subscribing. So we've got to first of all work out how many parts there are altogether. So we're told that the ratio of red, yellow and green is 3 to 2 to 4. So to work out how many parts there are altogether, we do 3 plus 2 plus 4, which is 9 parts. So there's 9 equal piles of sweets. Okay, but to work out what one part or one pile of sweets is worth, we're going to get the 99 sweets and divide it by the amount of piles, and that's going to be 11. So one part is worth 11 sweets. We're asked to find out how many yellow sweets, and yellow is the middle one, so it's going to be the 2. So yellow has 2 piles of 11 sweets. 2 times 11 is going to be 22, so it's going to be 22 sweets. To answer this question, we need to cut this shape into 2 shapes. So we're going to draw a line across here, and we're going to cut it into a rectangle and a triangle. Now we need to first of all label the parts of the triangle. So the length or the width of the triangle, the base, will be the same as the base at the bottom, so that will be 20 centimeters. And we need to find the height, which is this length here, which is 90 degrees to the base. And to find that, what we can look at is the fact that the total height of the whole thing is 13, and the height of the bit we don't want is 11. So what's left over? Well, 2 centimeters will be left over, so the height will be 2 centimeters of the triangle. So let's work out the area of the triangle first. Which is going to be half times base times height. Half times the base, which is 20, times the height, which is 2, will just give us 20. Now let's work out the area of the rectangle. And that's just going to be the width times the length. Width is 20, the length is 11, so that would be 220. Then to work out the total area of the whole thing, we're just going to add those together. So 220 plus 20, which is 240. The units are all in centimeters, and so the area units will be centimeters squared. So we're going to start off by filling out this table. So 0 times 1, 0 times 2, 0 times 3, 1 times those, 2 times those, and 3 times those. And we're looking for the probability that the product, which just means that when we times them together, will be more than 2. So which of these are more than 2? Let's circle all the ones that are more than 2. And to work out a probability, it's always the successful outcomes over the total amount. So the successful ones are the ones I've circled, so 1, 2, 3, 4, 5, 6, 7, 8, 9. The total are all of them together, where it's a 4x4 grid, so it'd be 16 in total. And so the probability that the product will be more than 2 will be 9 over 16. A plan is a view that you would get if you were on top of the shape. So you were in an airplane or something looking down on the shape. So the sides of this that we'll see, well, we'd see this bit here, and we would see this bit here. So I'm going to start off with the first bit I shaded, and we've got to figure out what the different lengths will be. Well, this would be 2 centimeters across, and the whole thing is 8 centimeters. The bit we don't want is 3 centimeters, so this part here will be 5. It would look like it was 5 wide. So let's draw that on, and so we've got 2 centimeters down, and we've got 5 across. 1, 2, 3, 4, 5. And this is what it would look like from above. Now the other part will be same 2 centimeters, but it will be 3 centimeters across. So we have 3 centimeters across. Now whenever you have a join or a change in elevation, you need to show that with a line across, and so this will be our completed answer. The front elevation of a shape is the view you'll get if you were standing at the front. So if you imagine you're standing here, the only side you will see is this side here. And what will it look like? Well, it will look like a complete square or rectangle. And how high will it be? Well, it will be 6 centimeters high. And how wide will it be? Well, it will be 2 centimeters wide. So what we're going to do is we're going to just draw a rectangle that is 2 centimeters wide and 1, 2, 3, 4, 5, 6 centimeters tall. There we go. And make sure that you don't add any 3-dimensional aspects to it, that you don't do something like this, have some 3D stuff on it. No. Whenever you do a front elevation, it's exactly perfectly 2-dimensional. So what we need to do is find out where the graph is at its highest, and so it's highest here. And so if we go down from there, we find out what year it is. Well, these years seem to be going up in 1, so that's 1950, 1951, 1952. So the answer would be 1952. The area of a trapezium is found using the formula area equals half a plus b times h. Now a plus b are quite easy to find because they are the parallel sides in the trapezium, which are these two. It doesn't matter which way around we label them. I'm going to say a is the right hand one and b is, or left hand one, and b is this right hand one. Then h always hits a and b at 90 degrees. So if we have a look at some of these lengths, this length at the top here is touching the A and B at an acute angle for A and an obtuse angle for B, so that is definitely not the height. This length here, same thing. It's hitting the A at an acute angle and B at an obtuse angle, so that is not the height. The height is actually going to be this length here, because you can see it hits both A and B at 90 degrees. So let's fill this into our formula. So it's going to be half times A, which is 8.7, plus B, which is 5.3, and then times that by the height, which is 2.4. That's going to be half times 14 times 2.4. That's going to be 7 times 2.4, and then that will be 16.8. All the units in the diagram are in centimetres, so our area will be centimetres squared. So we start off by working out what 100% of 240 is. Well, that's obviously going to be 240. And a nice easy one to start off with is 10%. And we're trying to get to 21%, so 10% is always a good one to start with. So we divide by 10, which would be 24. And because we try to get to 21%, we'll need to find out what 1% is. 1%, we just divide the 10% by 10 again, so it would be 2.4. And then we need to find out what 20% is. And 20%, we just double the 10%, so it would be 48. And so 21% is this plus this, because 1 plus 20 is 21. So we add these together, so 2.4 plus 48. Probably don't need to do this formally. Probably do this in our heads. So 50.4, but it says to increase 240 by that amount. So we need to get 240. We need to add the 50.4. Probably, again, don't need to show the working out for this. We can do this in our heads, but It's a bit easier to see what we're doing. So the answer would be 290.4. So we have a set of vertically opposite angles here and here. And we're going to start with those because we have to find out what m is before we can work out what x is. And vertically opposite angles are always equal, so we've got 13m plus 39 is going to equal 2m plus 149. And we're going to get our lines in there because we're going to solve this. And to solve this, we first of all take away the smaller amount of m because we've got m's on both sides. We can't really cope with that when we're solving. And so we've got a 13m and a 2m. So we're going to remove the 2m. We're going to take that away from both sides to start off. And so we're left with 11m plus 39. And we've just got the 149 on the right hand side. Next we're going to remove the number. So take away 39 from both sides. And we've got 11m is equal to 110. And then we're going to divide both sides by 11 to find out what m is. So m therefore equals 10. So we know if m equals 10, we can then work out x. And the way we can do that is the fact that this one and this one are both on a straight line. So they are both on this straight line here. So we know that they've got to add up to 180. So let's write that down. 13m plus 39 plus x is equal to 180 degrees, or I don't normally put that in for the working out, I always put that in for the answer. So we can solve this, or well, first of all we know what m is, so it'd be 13 times n, which is 130, and then we can solve this. So let's get my solving lines in. And so that's going to be 169 plus x equals 180. And we're going to just take that away from both sides, the 169. So we've got x equals 11. So the value of x will be 11 degrees. For mutually exclusive events for a and b, the probability of a or b is equal to the probability of a plus the probability of b. Now we're given the probability of a or b, which is 0.36, and we're given the probability of a, which is 0.12. And so to work out the probability of b, all we need to do is going to solve this. We're just going to take away 0.12 from both sides, and that will give us 0.24 is equal to the probability of b. So b must be 0.24. It only works if a and b are mutually exclusive though. So to draw this straight line graph, what we're going to do is just pick three x coordinates, which is -2, 0 and 2. So I'm going to start off with -2, and I'm just going to substitute it into the equation we've got here. So y equals -2 times -2, because that's what we're putting in, plus 8. -2 times -2 is positive 4. So it's going to be 4 plus 8, which is going to be 12. So at -2, our graph is at 12, which will be here. Then we're going to put in x equals 0. So it's going to be y equals -2 times 0 plus 8. Anything times 0 is just 0, so it's just going to be 0 plus 8, or just 8. So it's going to be 0, 8 will be our next coordinate. And then finally we've got x equals 2. So it's going to be y equals -2 times 2 plus 8. -2 times 2 is going to be -4. And -4 plus 8, which is the same as 8 take away 4, so that's going to be 4. So at 2 it's going to be 4. So we get our ruler to be able to draw this in. We try our best to make sure it's as neat as we can, and make sure it continues on for the whole graph, so no gaps. Instead of doing 0.43 times 16, what I'm going to do is I'm going to do 43 times 16. So I'm just going to get rid of the decimal and just change it to 43. But I've got to remember what I've done. So how have I managed to do that? Well, I've times it by 100, and that'll be important at the end. And to do 43 times 16, there are loads and loads of different methods. Just pick whichever method you enjoy doing or that you find easiest. I'm going to do the grid method, but it by no means is the best method. It's just the one I'm choosing to do. So 43 is 43, and 16 is 10 and 6. So 40 times 10 is 400. 40 times 6 is 240, 10 times 3 is 30, and 3 times 6 is 18. Then I'm just going to add them all together. So 400 plus 240 plus 30 plus 18. And when you add those all together, you get 688. Okay. Now, the problem is that obviously this is not going to equal 688. What we've done though is we've timesed it by 100. So to find the answer, all we need to do is divide this, undo that times by 100, so divide it by 100. When we divide that by 100, we get 6.88. We're going to first of all work out how many parts there are in total. So we've got James with 9 parts, 6 for Andy, and 7 for Tia. So in total we've got 9 plus 6 plus 7, which is 22 parts in total. And we're asked to find a fraction Tia receives. Now Tia's the last one, so she is receiving the 7 parts. So it's 7 out of 22. So we've got to first of all find out what the gradient is for our graph. So we'll just go pick 2 points and draw a triangle between them. So I'm just going to pick this point here and this point here. And there's no reason I picked those. Just pick those at random. And we look at how far it's going to cross. So it's gone across 10. How far it's gone up. So it's gone from 24 to 36. So it's gone 12 up. And to work out the gradient, which you can call n, or you can just write out the word gradient, it's change in y over change in x. So how much has y changed over how much has x changed? So y is this one here, so it's changed by 12, and x has changed by 10. So it's 12 divided by 10, which is 1.2. Now a gradient represents the amount of change in the y per one change in the x. So for every 1 mile we travel, we're going to go up, it's going to cost 1.2 more. So the interpretation that we give for this context, because this is about taxis, is that the taxi will cost £1.20 or 120 pence per 1 unit on the x per mile. And that's true for the gradient for any context. It's for every one of this, how much of this increases, how much the y increases by. So the rules of indices state that if you have a power inside and outside of a bracket, we just multiply them together. So it's 10 to the power of minus 12 times minus 12. 2 negatives make a positive, and 12 times 12 is 144. So the first thing we're going to do is write this as a ratio between the fractions. So we're going to have green to black. Now it says that a quarter of the counters are black, and therefore the remaining counters will be green. So if a quarter are black, that leaves 3/4 to be green. And what we can do here is on both sides of the ratio, what I'm going to do is just times it by 4. So I'm just going to times 4 both sides. So 3 divided by 4 times 4, because over 4 just means divided by 4. So 3 divided by 4 times by 4 just gets rid of the fraction. And 1 divided by 4 times 4 is just going to be 1. Now this might surprise some people because they will probably think it's a ratio of 4 to 1. But we can show here that it's a ratio of 3 to 1. So this question is asking us really to divide the 5 3/4 by 1 3/4. So we're going to do 5 3/4 divided by 1 3/4 because we're finding out how many of each of these towels, which is 1 3/4 meter, can be made when the total amount of cotton is 5 3/4. So first thing we're going to do is convert them to mixed numbers, to top-heavy or improper fractions, because at the moment they're mixed numbers and we can't divide or times if they're mixed. So we times the 5 by the 4 and add it to the top, which will be 20, and then add it to the top 23, and then do the same. 1 times 4 is 4, plus it to the top is 7/4. Now a little trick here is KFC. We keep the first fraction, we flip the second fraction, and we change the divide sign to a time sign. So we're going to keep this first fraction as it is, change that divide to a times, and flip the second fraction. Okay, whenever we multiply, we just multiply the tops, so 23 times 4, which is 92, and we times the bottoms, which will be 28. And now we need to convert this back into a mixed number. So first of all, actually we can simplify this because we can divide top and bottom by 4. So that would be 23/7, and then make this a mixed number. So 7s into 23 go 3 whole ones, and then obviously 2 remainders, so it's 2/7. Now it asks us for the amount of towels that she can sew patterns into. Now the issue here is that she will do 3 whole towels but then have some left over, but she doesn't have enough to create a 4th towel, so it's just going to be 3 as an answer. So I'm going to write this out again just to give us a bit more space, and the way we're going to solve this is exactly the same as if we had an equation there, well, with an equal sign obviously, but with this one, if you times or divide by a negative, you've got to flip the sign. We're not going to be doing that in this one, but that would be one of the differences. So we're going to take away 10 both sides to get 7x on the left hand side. Make sure you don't put an equal sign in there, otherwise that is instantly 0 marks. Then we're going to divide by 7 both sides to get x on its own. So it's x is greater than or equal to 11 would be the answer. To find out what the value of x is, we first of all have to find out what the value of y is. And we can notice that we've got 2 sets of parallel lines here, and a line going through them. And we kind of got these f angles, which we have to call corresponding angles. So we know that 2y minus 50 is equal to 78. And we must write down the reason, so corresponding angles, and corresponding angles are equal. Now here we've got an equation and we want to solve it, so we get our lines in. We'll go first of all add 50 to both sides. So we've got 2y equals 78 plus 50, which would be 128. And then we're going to halve both sides, or divide by 2. So we've got 64. So we know that y is 64. And so we look back at the diagram to find out how we'd work out x. Well, what we can do, there's a few different things we can do. We could work out the fact that these two here are vertically opposite. That would be absolutely fine. But actually, if we look at this part here and this part here, these are also 2 parallel lines, and we've got this angle here and this angle are going to be alternate. So I can write that down here. So angle ECB is equal to 78 degrees. So this will be 78 degrees. And the reason for that is alternate angles. And then finally, if we know this is 78 and we know that this is 64, because we know what y is, then we can work out what x is. So x equals 180 angles in a triangle, take away the 78 we know and the 64 we know. And the reason for that is angles in a triangle add up to 180 degrees. And just make sure you write down all the reasons as you go. And when we take away the 78 and the 64 from 180, you get 38. So x is therefore 38 degrees. So we're going to start by understanding that all lines form or can form an equation y equals mx plus c, with m being the gradient and c being the y-intercept. It says here the gradient is -2, so we've already got a bit of a head start with this, but we don't know what the y-intercept is. So we're going to use this first set of coordinates to work out what the y-intercept is. So y is -31 and x is 15. And we're going to use this to solve and find out what c is. So first thing I'm going to do is, well, just tidy this up. 2 times 15 is 30, so -30 plus c. And I'm just going to add 30 to both sides to get c on its own. So that would be -1 equals c. So c is -1. So we now know that the equation is y equals -2x minus 1. And we're told that the y is -37. And we're looking for the x value, which they've called w. So let's get our solving lines in. Okay, so the first thing I'm going to do is add 1 to both sides. And so it would be -36 equals -2x. I'm going to now times, or divide everything by -2. And a negative divided by a negative is positive. 36 divided by 2 is 18. And then obviously that gets rid of the coefficient of the x, so it's just x. So x equals 18. So the x value is 18 and the x value is the w value. So w is 18. We're going to first of all have to convert these both into the same unit. So we've got minutes and hours. That's not going to help us much. So what I'm going to do is pick the smaller unit, which will be minutes. So I'm going to keep that 50 minutes. And I'm going to convert 3 hours into minutes. That would be 180 because we times by 60. And I'm going to just remove the minutes now. And I can first of all divide by 10, and we want to try and make it nice and simple for ourselves. So divide by 10 would be 5 to 18. And we look at it, 5 and 18, actually there's nothing further we can do with that. So the ratio would be 5 to 18. To work out the area of a rectangle, we just multiply the width and the length. Here they are mixed numbers, so all we do is the width times the length. Now when you multiply with fractions, always make them top heavy first, or improper, and to do that you times the big number by the bottom and add it to the top. So we're going to do 1 times 2 and add it to the top, so 3 over 2. Same with this one, 1 times the 3 at the bottom, added to the top. 1 times 3 is 3, add to the top is 5. Now we've got to get the numerator, we don't need to get the numerator the same, we're multiplying. All we do now, really easily, is just multiply the tops and multiply the bottoms. So we've got to convert 15 over 6 into a mixed number because it asks for a mixed number. So 15, how many 6's go into 15? Well, we're first of all going to have 2 whole ones. And how many left over? There are going to be 3 left over. Now, 3 over 6 is the same as 1/2 because we can divide top and bottom by 3. So our answer is 2.5. I'm just going to write the question out so we've got a little bit bigger writing to play with here. And it doesn't actually matter which method you expand these brackets with. I'm going to use Smars and Rainbows. So we multiply the 8 by the 10x, which will make 80x, and multiply the 8 by the 4, which will make 32. Now here we've got a -5 on the outside, so we do -5 times 8x, which is -40x, and -5 times -4, which is actually plus 20. And a lot of students will write take away 20 there, but that is a minus 5 on the outside of the brackets there. So it's minus 5 times the minus 4 there will give you a plus 20. Then 80x take away 40x, which will give us 40x. And 32 plus 20, which would be 52. So our answer would be 40x plus 52. To answer this question, we need to know what an equation, expression, formula, and identity is. So the formula is basically an equation, but for real-world things. So area equals pi r squared. It's where the letters actually mean something. Expression is just algebra without the equal sign. So 5x plus 3 would be an expression. An equation has an equals and it can be solved, so you can find out what x is or find out what a is. And an identity is true for all values of that letter. So an example would be x times x equals x squared. That's an identity because that's true for all values of x. So looking here on the right hand side, we've got 3x plus 2x. But if we imagine x is 10, so 3x would be 30 plus 2x would be 20, 30 plus 20, well that will equal 5x, 5 times 10. And actually this is true for all values of x. And the reason it's true for all values of x is we know that 3x plus 2x, this right hand side here, equals 5x. They're the same thing. Now normally with an identity, it's shown with 3 lines. Now in the exam, this type of question, it won't be shown with 3 lines because that kind of gives it away that it's an identity. But this question is definitely an identity. And you can't solve it because it's true for all values of x. So yes, x could be 10, x could be 1,000,000, x could be 1/3, x could be anything. We're going to start by looking at the numerator and the denominator separately. So looking at the numerator first, we've got 9 to the power of 16 times 9 to the power of 46. Now when you have two powers of the same base, so they're both 9, base 9, but base is the big number, then what you can do is you can add the indices. So we're going to do 16 plus 46, which is 62, so it's 9 to the power of 62. And looking at the denominator, well, you've got a power inside and outside the bracket. Whenever you have that, you can just multiply them. So it'd be 9 to the power of 40. Now, whenever you've got a division between two powers of the same base, which we have here, it's 9 to the power of 62 divided by 9 to the power of 40, we just take away the indices. So it'd be 62, take away 40, which will be 9 to the power of 22. So our answer is 9 to the power of 22. So we know that the equation of all linear graphs, which we have here, is going to follow the y equals mx plus c. And we need to find out what the m and the c are. So we're going to first of all work out what the gradient is. So that's going to be m. And the gradient is the change in y over change in x. And a different way we can write that is y2, so the y coordinate of the second coordinate, the y component in the second coordinate, take away y1, over x2, take away x1. And so y2 is going to be the y coordinate of the second component, which is there. That's going to be 40, take away y1, which is going to be 31. And then that's going to be over then the x component, so 24, take away 18, which is the x component for the first equation. So it's going to be 9 over 6, which is going to be 3 over 2, because just simple cancelling. So we know that m is 3 over 2, so we can actually just write out that that's going to be 3 over 2x. But we still don't know what the y-intercept is. So what we can do is have a look at the first coordinate. And for the first coordinate, we've got an x and y coordinate. So we know what x and y are. So what I'm going to do is just write out the equation I've just written out. But instead of writing y, I'm going to write in 31. instead of writing x, I'm going to substitute in the 18. So it's going to be 31 equals 3 over 2 times, and the x component was 18 for our first coordinate, and then we've got the plus c. And so all we need to do now is solve it. So there's going to be quite a few components here. We're going to do 3/2 of 18 first of all. So 3 over 2 times 18, well, that's going to be 27. And then we're going to subtract 27 both sides. And when we do that, we get the fact that c equals 4. Now, if we know what c equals 4, we can then substitute that into what we know. So it's 3 over 2 x, and we know that c is 4, so it's going to be plus 4. Let's write that in our answer. So 3 over 2, it could be 3x over 2. You could put the x into the fraction and then plus 4. So here we're asked to find how many bread rolls we can make. We've got 89 kilograms and it takes 0.08 kilograms to make a bread roll. Something we can do is convert these into grams, or we can just keep it at kilograms, but I've got a neat little trick. And the trick is, if you've got a decimal when you're dividing, as long as you do the same thing left and right, you can multiply them by 10 or 100. In this case, we're going to multiply both by 100 because it will make the division a lot easier, because it will make this right hand side, instead of 0.08, it will just make it 8. The reason we can do that is 89 divided by is the same as 89 over 0.08. And as a fraction, we can just times top and bottom by 100. So it would be this over 8. So now we can do the bus stop method. So 8 on the outside. And in fact, I might use a straighter line here. There we are. And we've got 8,900 on the inside. So 8 into 8 go 1, 8 into 9 go 1, remainder 1, 8 into 10 go 2, remainder 2, and 8 into 20 go 2, remainder 4, and 8 into 40 go 5. Now it says how many bread rolls can we make. Now we can make 1,122 and a half. Well, half doesn't really count, so we're just going to say 1,122 whole bread rolls. Yes, we've got half a bread roll left over, but we are asked how many whole bread rolls can we make. So in this question, we basically need to add the 2 3/4 and the 2 2/5. So we're going to do 2 3/4 plus 2 2/5. Now, if I just rewrite this, 2 3/4 can be written as 2 plus 3/4 plus 2 plus 2 1/5, or 2/5. So we can add the two 2's together to make 4, and then all we need to do is add the 3/4 and the 2/5. So when you add two numbers with different denominators, what we need to do is get the common denominators. And we do that by just quickly writing out the 4 and the 5 times table and seeing what the first number in both their times tables is. 16, 20, and 5, 10, 15, 20. So that's 20. So we need to get the bottoms of the fractions to 20. Now for 3/4, to get the bottom to equal 20, we need to times the 4 by 5. And whatever you do to the bottom, you've got to do to the top, so times that by 5 as well, which will be 15. And for 2/5, we'll get that bottom to 20, so we times that by 4. And so we've got times the top by 4 as well, to make it 8. So it's going to be 15 over 20 plus 8 over 20. So we need to add the numerators. So it'd be 15 plus 8, which is going to be 23 over 20. Now that is a top-heavy fraction, so we can rewrite that as 1 3/20. And we can add the 4 and the 1 together to make 5 3/20. So the answer is 5 and 3/20. What I'm going to start off by doing is rearranging this equation so that it kind of matches this one. So I'm just going to write it down. And we want the n to be -2. So what I'm going to do is I'm just going to put my rearranging lines in, and we're just going to add 10 to both sides. Now, we've already got this line drawn for us on this graph. And so all we need to do is draw this line. So we've got y equals 10x squared plus 8x minus 2 drawn for us. We just need to draw this line, which is y equals 10, and see where they cross over to find the solutions. So y equals 10 will be all the way up at the top. Let's just make sure I get it nice. There we are. I need to move that up a little bit. There we are. And let's read off the values that gives us. So it comes down here, and it comes down here. So the values it comes down to are -1.6 and 0.8, and those are our solutions. In this question we have a right angle triangle and we know 2 of the sides and we're looking for the third one, so that screams to me Pythagoras. So Pythagoras is a squared plus b squared equals c squared, with c squared being the hypotenuse. The hypotenuse is the one opposite the right angle, so this is going to be c. And we'll label the other ones a and b, it doesn't matter which way around they go. So a is 5, so it'll be 5 squared plus 12 squared equals c squared. 5 squared is 25, 12 squared is 144. And so 25 plus 144 is 169. Now that's c squared, so we need to solve here. And the way to solve is just to square root both sides. And so it would be 13 equals c. Because it's distance, we don't worry about the -13, so just the +13. So we know c is 13. So we need to know what the total length around the triangle is. So we're going to add the 5, the 12, and the 13 we've just found. When you do that, you get 30. So we know there's 30 meters in total. Now it does say that we need 90 milliliters of paint per meter of wood. So the amount of paint needed is going to be the 30, because that's the total distance, times the 90, because we need 90 for every meter of paint. 3 times 9 is 27, and then put the 2 zeros at the end. So the answer is 2,700 milliliters. So to answer this question, you need to just know the answer off by heart. There is a diagram that can help us actually get there. And if we just draw a right angle triangle and put the lengths as 1, not right angle here, we can use Pythagoras, a squared plus b squared equals c squared, to work out the fact that this is going to be √2. Because it's an isosceles triangle, this angle here is going to be 45 degrees, and same with the bottom right one, but we're not interested in that. When we label it with our marked angle here, we've got the adjacent is here and the hypotenuse is here. Now we know from trigonometry that cos x equals a over h. The angle is going to be cos 45, and a is going to be 1, and h is going to be √2. Now, this is a bit of a strange one with 1 over √2, because we need to actually be able to rationalise the denominator. And basically what that means, if you haven't done surds yet, or you aren't doing surds, is you times Tom1 by √2. And so we end up with √2 over 2. So if you ever see 1 over root 2 is absolutely fine as an answer, but if you ever see the answer as root 2 over 2, the two are actually exactly the same. So writing 1 over root 2 is fine, or writing root 2 over 2 is also correct. So we're going to first of all realise that this is a right angle triangle and we've got two lengths and an angle involved, therefore it's going to be trigonometry. So we're going to just label the sides first. The one opposite the right angle is the hypotenuse, opposite the marked angle is the opposite, and the one between the right angle and the marked angle is the adjacent. Now the adjacent doesn't have a number or a letter next to it, so it's not interesting, so get rid of that. Next we're going to do our trigonometry triangles. And so we've got SO, Ka, Toa. And we have just crossed out the adjacent, so we don't need this one and we don't need this one. And we're going to end up with SO, which is short for sine the angle equals opposite over hypotenuse. The angle is marked as x, so sine x equals root 3 over 2. You need to know from memory that sine 60 is root 3 over 2. And notice here that the x therefore is going to equal 60. So looking at the graph straight away, we know that the y-coordinate of point A is 0. And we're told that it's y equals tan x. And you just need to know the graph y equals tan x. And if you know the graph, we know that that will be 180 degrees. We know the point at which both of these lines will be going towards would be 90. This point here will be 270. And so therefore this point will be 360 degrees. So it's going to be 360, 0. The first thing to notice is we actually have two radii here. So we've got this radius here and this radius here. And all radii are always equal in length. So we have an isosceles triangle here. So this angle here is going to be 19x as well. And we've got to write that down. So we're going to say angle OBA is equal to 19x. And the reason is it's an isosceles triangle. Okay, so we know these two are equal. Well, we also can work out x because, as I said before, we have a triangle here. And all angles in a triangle add up to 180. So we've got 7x plus 19x plus 19x equals 180 degrees. And this is angles in a triangle. Try and draw a better triangle, equal 180 degrees. Try and write out these reasons in full. Okay, so that's going to be, was it 45x equals 180. And let's get our solving lines in. And we're just going to divide both sides by 45. Okay, so we've got x equals 180 divided by 45, which is 4. Now, we're looking for this angle here. That's angle ABC. Now, there's a few different ways we could do this. We could work out what this angle is, because it's a big triangle, etc., etc. Or we can use the fact that we've got a tangent touching a radius. So we know that this, let's just pick a different colour, this angle here is 90 degrees. So we can write that down. So angle OBC equals 90 degrees because it's the angle between a tangent and a radius. Again, make sure you write all the reasons in full. And so therefore, angle ABC, which is what we're asked for, is just 90, take away the 19x. Well, we know that 19x is 19 times 4, because we know that x is 4. And so that would be 76, so in total it would be 14 degrees. So angle ABC is 14 degrees. I'm going to start by getting x equal to the 0.847 recurring. And I'm just going to show that with 3 dots. And we want to bring forward everything that's not part of the recurring pattern. So what I'm going to do is I'm going to find out what 10x is. And that's going to be 8.8 8.4747. So what I've done is I've just got the recurring pattern after the decimal point. And what I want to do now is bring forward one of the occurrences of the recurring pattern, so the 4 and the 7, just one of them. So we're going to times it by 1,000. We'll find out 1,000x, and so it'd be 847.4747, etc., etc. Next, I'm going to take away everything. So 1,000x take away 10x, and that's going to be 990x. And then 847.4747, etc. Take away 8.4747, etc. It's just going to be the same as 847 take away 8, because the recurring stuff will just cancel each other out. So 847 take away 8 is 839. And now I'm just going to put my lines in. And so what I'm going to do now is just divide both sides by 990. And so on the left hand side we've got x, and on the right hand side we have 839 divided by or over 990. So as a fraction it's going to be 839 over 990. When we add fractions or integers and fractions, we need the denominators of the fractions to be the same. And when we've got an integer, we just convert it to a fraction. And here we've got 9k, and we need to convert that to a fraction that is over k plus 9. And the way we do that is we get the 9k and we times it by k plus 9 over k plus 9. And effectively k plus 9 over k plus 9 is just 1. So we're doing 9k times 1. So we're keeping it the same. We're keeping it as 9k. So what we do when we times a 9k or a term by a fraction is we times the top, the numerator of the fraction. So it's going to be 9k brackets k plus 9, and all of that over k plus 9. Expanding the brackets, we get 9k squared plus 81k over k plus 9. And so what I'm going to do is just feed that back in here. And so we've got 9k squared plus 81k over k plus 9, which is just that 9k bit, plus 11 over k plus 9. And whenever we're in this situation here, we just add the numerators. So it's going to be 9k squared plus 81k plus 11, and all of that over k plus 9. And that will be our answer. So let's put that in our answer field. So we're given the equation of the line, which is y equals ka to the power of x, and we're given two coordinates. So we're looking at this first coordinate and put that into the equation. So y is 10 equals ka to the power of x, which is 1. And we're going to do the same with the other coordinate. So we've got 40 equals ka to the power of x, which is 3. Now look at what's happening to both sides. Here we're multiplying by a squared. So a to the power of 1 times a squared is a to the power of 3. And on this side we're multiplying by 4. So we have to be able to conclude that a squared equals 4. And if we square root both sides there, a must equal 2. So if a equals 2, we can just put that into the first equation here. So we've got 10 equals k times 2. And divide both sides by 2, and we get 5 equals k, or k equals 5. So our answers will be k equals 5 and a equals 2. Now check that works. So let's have a look at this second coordinate. and we're going to do y equals, and we're going to do 5 times 2 to the power of 3. 2 to the power of 3 is 8. 5 times 8 is 40. So we know that our equation works. The first thing to notice is that 125 is 5 cubed. So instead of 1 over 125, it would be 1 over 5 cubed. And we know that when you have a negative power, it actually turns into the reciprocal of that number. So 5 to the power of minus 3 becomes 1 over 5 to the power of 3. So n is going to be this minus 3. When asked to simplify an algebraic fraction, you will almost always need to factorise either the numerator, the denominator, or both. On this question, we need to factorise both. So I'm going to start off by factorising the top. Now you'll notice that this is a difference of 2 squared, so this is nice and easy to factorise because it will be x plus 2 and x minus 2. And we've got loads of videos on how to identify and deal with difference of 2 squareds if you don't know how to do that. Similarly, the bottom is just a simple quadratic, so we're just going to factorise that. Again, we've got videos on how to factorise quadratics, so have a look at those if you need to. Then we're going to look at top and bottom and see if there's a bracket that's the same, which there is, this x minus 2. So we're going to divide top and bottom by x minus 2, and that will effectively get rid of the x minus 2 at the top and the x minus 2 at the bottom. It won't get rid of it, it will just turn it to 1, and then it will be x plus 2 times 1 and 2x minus 3 times 1, which will just be x plus 2 as the numerator and 2x minus 3 as the denominator. So with all these circle theorem questions, there's multiple ways of doing it. I'm going to show one way, but if you've got a different way and you get the right answer in correct methods, then please feel free to use that. First thing I'm going to notice is we've got a lot of tangents touching radii. So we've got 2 radii here and here. And whenever we've got a tangent touching a radius, it's always going to be 90 degrees. And so I'm just going to show these all on the diagrams 90 degrees. And then we're going to say angle OBC equals angle OBA equals angle ADO equals 90 degrees. And we have to show the reasons. Most of the marks in this question will be for the reason. So it's going to be a tangent radius equals 90 degrees. And try and write out the full reasons. I'm going to just keep it a little bit contained, just so I can fit this answer all on the same slide. Okay, so the first thing I'm realising is that there's a nice little quadrilateral here. And whenever we've got quadrilateral and we've got 3 of the sides, we can work out the last one. So angle DOB is going to be 360. Take away the angles that we know, so 90 plus 90 plus 48. And the reason for that is angles in quadrilateral add up to 360 degrees. And so when you do 360, take away that, you get 132 degrees. So this is 132. But we also have this angle here, which is also angle DOB, but I'm going to call this kind of the reflex one. And to work this one out, we just do 360, take away 132. And the reason for that is angles on a point equal 360 degrees. And so we're going to do 360, take away 132, which is 228. So this is 228 degrees. Now we can also use the circle theorem to work out this one, because we've got an angle at the centre and an angle at the circumference, and the angle at the centre is twice the angle at the circumference. So angle DFB is going to be 132 divided by 2. Angle at centre twice angle at circumference. Okay, so when we halve that, so 132, and we're going to halve it, so that's 66 degrees. We should really put degrees on these. Okay, the next one we're going to work out is this angle here, which is angle OBF. There's no reason for this, it's just the whole thing is 90. We're taking away the 77, so that would be 13 degrees. So that's a nice easy one. And let's just put the 66 degrees on our diagram as well. And the final thing really here is that we've got a quadrilateral here, kind of arrowhead. And we've got 3 of the angles, 1, 2, 3, and we're looking for the third one. So angle ODF is going to be 360, take away all the angles that we know. So the 228, the 13, and the 66. And the reason being the same as before. So angles in quadrilateral add up to 360 degrees. And when you do that, you get the answer of 53 degrees. So this angle here is going to be 53 degrees. I'm going to rewrite the question first of all. Whenever we've got a square on the outside of a bracket, it just means we're going to times the bracket by itself. Now the way we can expand this is very similar to the way we expand with quadratics. Now you might have a different method like FOIL or something else. I'm just going to do the grid method. Doesn't really matter which method you choose. So we're going to do 11 and root 2 at the top and 11 and root 2 down the side. So 11 times 11 is 121. 11 times root 2 is 11 root 2. We've got another 11 root 2 there. And then root 2 times root 2. Well, you times the numbers together, it's going to be root 4. And root 4 is 2. So that's just going to be 2. Add the numbers together. So 121 plus 2 is going to be 123. And then add the surds together. So we've got 11 root 2 plus 11 root 2. So that's going to be 22 root 2. Compare it to the expression in the question, a plus b root 2. The a will be 123 and the b will be the 22. So for this question, first thing to notice is there's a divide there, and we can actually just write this as a fraction. So 10 plus root 2 over 14 plus root 2. I'm going to keep the brackets there. We don't need them when it's in a fraction, but it will help us for the next step. So we're asked to transport this or change this into a fraction without a surd at the bottom. And so it's basically asking us to rationalise the denominator. Now, when you have two terms, including a surd at the bottom, we need to do something a bit special with this. And the thing we do is we times it by the opposite bracket. And what I mean by that is if it's 14 plus root 2, we times it by 14 minus root 2. And we've got to do the same to the top. And the reason for that is essentially here all we're doing is we're timesing it by 1, because 14 minus root 2 over 14 minus root 2 is just 1. So we're timesing it by 1, so we're not changing the fraction at all. Okay, let's draw a grid to work out what that will equal. And you can use any method you want. You can use double smiles and rainbows, FOIL, whatever method you have to multiply two such brackets. I'm going to start off with the top. The top is 10 plus root 2 times 14 minus root 2. So 14 times 10 is 140. 14 times root 2 is just 14 root 2. 10 times minus root 2 is minus 10 root 2. And then a minus and a positive make a minus, and root 2 times root 2 is just 2. Now, when you expand surdy brackets, these two and these two will add together. Okay, so we're going to start off with the numbers. 140 take away 2 is 138. And then we'll do the surd. So 14 root 2 take away 10 root 2 is plus 4 root 2. Okay, so the top is going to be 138 plus 4 root 2. And let's do the bottom. And I like these grids because you can see if you've made any mistakes quite quickly with these. You can check your working. So 14 plus root 2 times 14 minus root 2. You'll see why in a second we do the opposite. So 14 times 14 is 196. 14 root 2 minus 14 root 2 and then minus 2. So you can see here now there's a 14 root 2 plus minus a 14 root 2. Let's just cancel each other out to 0. So we get rid of the surd. And then 196 take away 2, which is 194. So we've got 194 at the bottom. Now something we notice here is that all the terms in the fraction are even, therefore we can halve everything. So 138 halved is 69, 4 root 2 halved is 2 root 2, and 194 halved is 97. And so that would be 69 there, and that would be 2, and then that would be 97. So there are many ways to solve a quadratic, but in this question we're specifically told to complete the square. So I'm going to start by just copying down the question. And when we're completing the square, we're interested in the x squared and the x term. And we start by just writing down a bracket with x, and then we're going to add or subtract the coefficient of the x term, half of it anyway. So the coefficient of the x term is minus 12, so half of that is minus 6. Close the bracket and write squared. Over here we're just going to see what that gives us. So it'd be x minus 6, x minus 6, and that would be x squared minus 12x plus 36. So this creates a plus 36 we need to get rid of. So we're going to take away 36. Then we've got the minus 20 from the question, and then it's an equation, so we get it equal to 0. And then finally we've got x minus 6 squared. Add the minus 36 and the minus 20 together, and you get minus 56 equals 0. Now we solve it, so we get our lines in, and let's solve this. So I'm going to use all the same colour maybe in the equation now. So we've got minus 56, so we're going to add 56 both sides. Get the right function, so plus 56 both sides. And that will give us, that will leave the x minus 6 squared on the left hand side equals 56. I'm going to square root both sides to get rid of the squared. So x minus 6 equals, and then square root of 56, we just leave as root 56. And then we're going to add the 6 to get x equals. And that will give us x equals, and then we've got a 6. Now, when you square root 56, you can get a plus or a minus. So it'd be plus minus square root of 56. So my answer would be 6 plus minus square root of 56. So the first thing to do is we want to find the roots from the sketch that we've got. And the roots are just where the graph crosses the x-axis. So we can see it crosses it here at minus 8. Crosses it here at 3. Crosses it here at 5. Now, what is special about roots? Well, roots are where the graph equals 0. It's where y is 0. And the only way to get to 0 is, for looking at this, is if one of these brackets is 0. So we're going to say, okay, well, let's have a look at the first one, x plus a. Let's get that equal to 0. Oh, equal to 0. So we're going to put in the first root in there. We're going to say minus 8 plus a equals 0. Add 8 both sides. A must equal 8. So if a equals 8, then the whole thing will equal 0. That's the first root done. Could do the same with the next one. X plus b equals 0. And this time the root is 3. So it's going to be 3 plus b equals 0. Take away 3 both sides, and you get b is minus 3. Then we're looking at the last one. x plus c. Look at the last root, which is 5. Oh, we're going to get it equal to 0, and then it's going to be 5 plus c equals 0. And take away 5 both sides, you get minus 5. And so if a is 8, b is minus 3, and c is minus 5, it means that at minus 8, 3, and 5, it will equal 0, which is what it does in our graph. Now you might say, well, why does a have to equal 8? Why can't b equal 8? It can. These can be in any order. And so if I wrote these in the opposite order, minus 5, 8 and minus 3 for instance, it would still be correct. You can complete a unique version of this paper by going to our onmaths site. Onmaths is full of free content to help you prepare for your exams, such as topic-based papers, demon questions and mini mocks. If you like what we do, please consider subscribing.